In this video, we're going to talk about alternating series. First, let's talk about what is alternating series. If you look at the infinite series, such as this, notice that the sign changes. It alternates. These are the type of alternating series. Now, I call this portion right here a sign changer. These three makes the term alternate signs. And we're going to talk about when alternating series converges or diverges. The alternating series converges if the numbers a of n is positive and satisfy these two conditions. First, limit as n approaches infinity of a of n has to equal to 0. By the way, if it's not equal to 0, then by the n-term test, the alternating series diverges if this does not go to 0. Second, a of n has to be greater than or equal to a of n plus 1, which means that a of n is non-increasing. So for example, a of 1, the first term has to be greater than or equal to the second term. And the second term has to be greater than or equal to the third term, and so forth. And another way of showing that this is non-increasing is when you find the derivative of a of n, it has to be negative. So let's take a look at some examples. Let's take a look at this example. This is an alternating series. And what is our a of n? A of n is 1 over n. It's the part without the sign changer. Now 1 over n is always positive from 1 to infinity. So we're good. Now let's check the two conditions. First, limit as n goes to infinity of 1 over n. Is that equal to 0? It is. So first condition is met. What about second? Is a of n greater than or equal to a of n plus 1? What is a of n? That's 1 over n. Is it greater than or equal to, what is a of n plus 1? Well, instead of n, substitute n plus 1, you get 1 over n plus 1. You cross multiply, you get n plus 1 is greater than or equal to n, which is true. This is always 1 greater than n, so therefore this is always greater than or equal to. Therefore, two conditions are satisfied, so we can conclude that this alternating series converges by the alternating series test. By the way, also note that another way of showing the second condition is, let's say that f of x is 1 over x. And what is the derivative of f of x? That's negative 1 over x squared. And since n equals 1 to infinity, this will always be negative. The first derivative is always negative. Therefore, f of x has to be decreasing. So this is a non-decreasing. This is another way of showing that 1 over n is non-decreasing. Either one is fine. Let's take a look at this alternating series. What is a of n? A of n is n over n minus 1. And notice n starts from 2, not 1. Why? Because if n starts from 1, this is undefined. That's why this one starts from 2. And from 2 to infinity, this is always positive. So we're good to go. Let's check the first condition. Limit as n goes to infinity of n over n minus 1. Is that equal to 0? No. As a matter of fact, this is equal to 1. So we could stop right there. We can conclude that this alternating series diverges by the n-term test. Let's take a look at this example. what is our A of n? A of n is 1 over quantity 2n factorial. And remember, 0 factorial is 1, so therefore it is okay to start from n equals 0 in this case. And this is always positive whenever n equals 0 to infinity, so that's okay. And let's check the first condition. What is the limit as n goes to infinity? 1 over quantity 2n factorial. That's 0. So first condition is satisfied. Second is a of n greater than or equal to a of n plus 1. Well, our a of n is 1 over quantity 2n factorial, and that's greater than or equal to, what is our a of n plus 1? That's 1 over quantity. Instead of n, you got to plug in n plus 1, you get 2n plus 2. So now you cross and multiply, you get quantity 2n plus 2 factorial, which is greater than or equal to quantity 2n factorial. And this is greater than the right side. So second condition is also satisfied. So therefore, we can conclude that this alternating series converges by the alternating series test.